I'm Viraj from Biodiversity Lab in NCBS. So I work on understanding population dynamics of tropical butterflies, and here I am particularly talking about role of resource availability and host specialization. So resources are a crucial commodity in living world, and then they affect in various ways such as through availability, their utilization and investment. So there are various studies on various organisms which explore this role of resource availability from bacterial communities to Drosophila to birds. And butterfly, due to their specialized interactions, are a compelling model for studying such interaction. So the studies on butterflies related to resource availability has been done in temperate region. This is mainly due to availability of long-term monitoring schemes such as UKBMS and EBMS. So such schemes are largely lacking in tropical landscapes. So for this, to address this gap, Indian Butterfly Monitoring Scheme was formally launched in 2021. So this is a unique scheme which combines opportunistic citizen size data and more structured time constraint data. So I am using data from this scheme for various projects. So based on this, I would like to introduce my questions. So do larger butterfly have smaller population size due to their greater resource requirements? Do they have lesser variation in population due to potentially k-leaning strategies? Does host specialization affect population size and volatilism? Let's say a specialized host do they have small population size and higher amplitudes? And do the psychological factor compound in determining population dynamics? So I am using a 10-year count data from this one IBMS monitoring site at Bangalore. So I'm fitting these generalized additive models which fits this smooth curve on count data annually, and based on area under the curve of this count data, we get this yearly abundance index. And I got the size estimate and specialization from as wingspan and host parent species from Butterflies of Bangalore field guide. So going to my result, by fitting these CAM models, I get 4 different kinds of flight period. So one is more pronounced, limited or closed curve, where there is an increase in count and decrease in count, which is more suitable for this kind of analysis. And this other kind, the second one, where we have increase and decrease, but then at the end it doesn't goes to 0. The third kind is the phenology does not align with the calendar year, but then this can be easily corrected by frame shifting. And the fourth one may be like the GAM models are not fitting properly, or the species have overlapping multiple generation. So the first and third kind are suitable for this kind of analysis. So based on that, I get this yearly abundance for each year, and I make plots something like this, which is like years, and this is just for orienting you, because based on these 1 and 3rd kind of flight period, I selected 18 species from the whole list, and I subsetted them based on their size in small, medium and large. So this is just a visual comparison, and it kind of looks chaotic. I tried fitting GLM models. So yeah, which shows slight negative correlation, but then it was not statistically significant. Similarly, I did for the specialization, divided the species in specialist versus generalist, and again the pattern is even more chaotic, and again the GLM does not show any significance. So that's why I am addressing the caveats in this study. So the methods, the GAM models that I used are more suitable for these univoltine species without overlapping generation, and only few species can be used in this model from tropical and subtropical regions. And within this single peak species, there might be species which have overlapping generation, but then we are not considering that here. So that might add into confounds. And there is a need for this detailed time series analysis. We are currently working on it. So yeah, and in this particular analysis, I haven't included climatic factors which might influence population dynamics, but we just received climatic data from IMD, so we will be comparing them soon. With that, I want to acknowledge my NCBS and Biodiversity Lab for support, and ICEP and University of Lucknow for giving me this opportunity. This committee members for guidance, and all the citizen scientists involved in IBMS. So IBMS is a community effort. So I encourage, if anyone is interested in hosting an IBMS site at their place, please talk to me or Krishna May. Thank you.
So you have what seems like a really interesting finding that there isn't a relationship, but then you have a whole slide saying, well, maybe I just didn't try hard enough. But surely you do have quite an interesting finding, which is that the negative one.
Yeah.
Do you see what I mean?
Yeah. But then unless we test for all this confound, which we can test because we can get that data, unless we try that, I can't like say anything about that. Yeah, but that is good.
So have you looked at whether there are any correlations between species that might be using the same host plant or the same broad niche, or are there no such species in your 18 species data set?
I haven't looked, but then that data also we recently got, so that is also in line, because there is Season Watch which are doing this phenology for plants, and then like 2 days ago only I received an email saying, oh, that data is available from JBIF. So we are going to look at those patterns as well.